Ladies and gentlemen, boys and girls, children of all ages, yesterday we started multiplying decimals by decimals using the hundredths grid. So we're going to go over some problems today, and then I'm going to give you some problems to start or to work on your own. Please look, because I'm going to ask questions, and since you have your computers closed, you'll be able to see me. Camden, this whole square is worth how much? 100 hundredths, so it equals 1. Chloe, each column is worth what? 1/10. 1/10. Thomas, each little square is worth what? 100. 100. So yesterday, you learned some of these. This wasn't the problem I was thinking of. But you had a problem similar to this yesterday, and about half of you missed it. And so we're going to show why. First, we need to know that every little square equals 100. So when you're multiplying, you're counting how many squares are shaded in by both of them. So our first step is to take 3/10, and we shade in 3/10. As my friend Chloe told us, each one of these is worth 1/10, so that is 3/10.
Are we doing this?
Yeah, you're doing it on your paper with me. Second, what's the answer then? What's your answer then? 6/10?
No.
Okay. Shh. Now we shade in the other factor is 2/10. And then we count. So Kaysen, how many little squares are shaded in? By both colors. 6. And each little square is worth how much? 100. So my answer should be
0.6.
600. Yesterday you had one that was 4/10 times 2/10.
800.
And it should have been 800ths. Many of you put 8/10. Many of you put 8/10. Because, how is it? Good. These are the ones that are shaded in by both. Right? And that is 6 that are shaded in by both colors. 6 little squares. And we already determined that each little square is 100th. So 100th, 200ths, 300ths, 400ths, 500ths, 600ths. Many of you put 6/10. 6/10 would mean this many would be shaded in by both. And 1, 2, 3, 4. 6/10 would mean all of this area. That's actually 36. 6/10 would mean, 1, 2, 3, 4, 5, 6. There was this much shaded in by both. That's equal to 6/10. Think of it as pennies, dimes, and dollars. Pennies, dimes, and dollars. The whole thing is $1. Each column or each row is a dime. Each little square is a penny. And if I said, hey, Kaysen, I owe you 6 cents, or I owe you 60 cents, and I gave you 6 pennies, you're not going to take it, right? No. He'll probably slap me in the face, which is okay. That's fine. I probably deserve it.
Probably.
So let's look at another one. 8/10 times 6/10. 8/10 times 6/10. Now let me emphasize, I know some people were frustrated yesterday because they didn't quite understand it as well as they thought they should. Well, I'm going to tell you right now that yesterday was the first day we did it. When I first learned to ride a bike yesterday, I fell off a couple times.
Me too.
You're not always going to get it the first time.
So what happened?
So don't be frustrated because your teacher is going to keep going over it until you get it. Your teacher's already posted 5 videos in the classroom of Google, 4 videos in the classroom of Google. Now, let me ask you this. I'm going to ask you, Tenley. Are you ready? Tenley, what is 17 times 1?
17.
Okay? So if I multiply a number by 1, it stays the same, right? What happens to 17 if I multiply it times 5, Tenley? It gets...
It's bigger.
It's bigger. So if I take a number, I multiply by 1, it stays the same. If I multiply by a number bigger than 1, that gets bigger.
Yay!
Are either of these factors greater than 1?
Yeah. No.
I mean, wait.
No.
None of them.
There's a decimal.
None of these, neither one of these factors is greater than 1. If I multiply something by a number less than 1, it's going to get smaller. The value is going to get less.
My brain is full like
Multiplying by 1, it stays the same. Multiplying by something bigger than 1, that factor gets bigger. Multiplying by something less than 1, the number gets smaller. Just think about it, okay? 7, let's look at an example. 7 times 1 is 7.
7.
I'm going to pick a number bigger than 1. Okay, 7 times 2 is?
14.
Okay, so 7 stayed the same when I multiplied it by 1, right? 7 got bigger when I multiplied it by 2, right? So if I'm multiplying by
3.
1/10,
Oh.
that means 7 has to get smaller because 1/10 is less than 1. Multiply by 1, it stays the same. Multiply by greater than 1, that factor gets bigger. Multiply by less than 1, it's going to get smaller. We did this patterns in multiplying the other day, last week or something, by powers of 10, or 10th, 100th, 1000th. And all we had to do when we were multiplying by a 10th is move the decimal point to the left one time. Is 7/10 less than, greater than, or equal to 7?
No.
less than.
Less than. It's 10 times less than. Or I divide it by 10. Dividing by 10 is the same as multiplying by 1/10. I'm just saying. Okay, so both of these are less than 1, which means my factors are going to be smaller than they are now. My product will be smaller than both of these factors.
Yeah.
So let's take 8/10 and 6/10. So how many hundredths are shaded in? By both. I'm sorry, by both.
48.
48.
By both.
That's 48 hundredths,
Are we doing this?
which means,
Yeah.
yes, I told you you were doing them all.
Wait, 1,
If I'm doing them, you're doing them.
5, 6, 7. Oh.
Wait, are we doing it?
Yes.
No.
For the love of Pete, people.
I know we all love you so much. Science.
For the love of Pete.
Who's Pete?
I don't know.
Do you think I'm
Repeats,
good at
brother.
Do you think I'm good at singing?
Repeats, brother.
Do you think I'm good at singing?
That was my question. Wait a second. You erased it.
Well, yeah, it was up there long enough. 4/10 times 6/10. 4/10 times 6/10.
Wait, what?
2,400.
Well, let everybody do it. They're coloring in, they're shading the block.
We're not there yet.
They're not there yet.
Are we there yet? Are we there yet?
Not yet.
Are we there yet?
Are we there yet?
Oh, sorry.
I'm there.
it all the way.
So Elijah, how many little squares are shaded in by both colors? Good, 24. So my answer is 2400. They have to be shaded in by both colors. This and that. So all the ones that are colored twice is 2400. Now, this shows you why it works and how it works. Now I'm going to show you the standard algorithm. How you do it in mathy stuff.
Mathy stuff?
Yes. I mean, because if I said, what's 25 times 19? You could do 25 groups of 19, and that's your example, that's your concrete looking at example.
I just used my
But now, if we're doing it in standard algorithm, what was the second one? 4/10?
4, yeah.
All right, so if you're multiplying by decimals, if there's a decimal in any of your factors, first thing you want to do is find out how many numbers are behind the decimal point in the problem. How many are there?
1.
No.
2.
2. The 6 is behind the decimal point. The 4 is behind the decimal point. So there are 2 numbers behind the decimal point. Then, after you know how many numbers are behind the decimal point in the problem, you ignore the decimal points for right now, and you solve it just like regular multiplication, which is what most of you are doing in your head anyway as we do these.
Yeah. No, wait, I can't. I can't do multiplication in my head.
Sophia,
Yes.
what is 6 times 4?
24.
24. Now in my problem, there were 2 numbers behind the decimal point. So in my answer, there needs to be 2 numbers behind my decimal point.
Whoa.
Wait, is this how to
Not
answer
so
for
cool.
The third one we did.
the third one?
I got you, bro. I got you.
Count how many numbers are behind the decimal point total in all the factors.
2.
6.
That's how many need to be behind it in the product. Now the one you had yesterday that many people missed,
Let's see it. 2.
you had 2/10 times 4/10. The majority of you all put 8/10.
I didn't.
I said majority, I didn't say please tell me if you didn't.
Yeah.
For the love of Pete.
And then the boom boom.
How many numbers are behind the decimal point?
2.
2. The 4 and the 2. I know there are 2 numbers behind the decimal point in the problem. There have to be 2 numbers behind it in the answer. Then I rewrite it.
0.8.
2 times 4, which is 8. There has to be 2 behind it in the answer.
0.08.
So I have to put,
Oh my gosh, I'm so smart.
Wow.
I said the answer. Okay.
So is me. Actually, yeah, so is me.
well, let's look at another one.
Nice.
You're going too fast.
There's going to be more practice.
Yeah. There is. Yahoo! Oh, my head.
Even if one of the factors is greater than 1. I'm not asking you to shade this, I'm just asking you to stop tapping and watch. Even if one of your factors is greater than 1, you still do the same thing. How many numbers behind the decimal point in the problem?
3.
3. Then there have to be 3 numbers behind the decimal point in the answer. I rewrite it, ignoring the decimal points, because what's going to happen? You're going to try and line up the decimal points when you multiply. You don't have to.
What?
That is why I asked you to rewrite it, ignoring the decimal point, and just write it as whole numbers. Now I just multiply 4 times 7, which is
28.
28. Thank you.
Yeah.
So that's 28 ones, or 2 tens, and 8 ones. Then I got to multiply 4 times 6, which is
24.
24.
Plus 2 is 26.
So plus 2 is 26, so that's 26 tens. So that's 2 hundreds and 6 tens. And 4 times 1 is?
4.
Plus the extra 2 hundreds I have?
Yes.
6. And how many numbers did I say were behind the problem in the end? 3.
3.
Now my first factor was 1 and 67 hundredths. And I multiplied it by a number less than 1. That is why it got smaller. I multiplied this by less than 1. That is why it got smaller. I multiplied this one by something greater than 1. That's why it's bigger than 4/10. We're going to have more practice with this, so don't worry.
Yay.
Boom. Shakalaka, peace out. God bless. Love you. Do something kind today. Save the bees. And subscribe to Keller GBB on YouTube. Thank you.
Bye.